So I was looking at the video from last time. And one weakness I thought was that I didn't really say what a scalar was. So I made this slide. That's just a number. Got it. Just a number. Okay. So here's my example. And a vector is a quantity and a direction together. So the first one's just a direction. The second one's just a quantity, and then the third one's together. Is that what you got from last time? Okay. So you could express a vector either as a magnitude and a direction, 60 feet away at 40 degrees, or you could express it with components. It's the same bird. It's 46 feet horizontally and 38 feet vertically. If there's anything that was unclear before, that's clarified, that's good. So a vector doesn't have a location, but you can use it at a location. Okay, so this vector, here, the vector Gary wants starts at 3, 8, but it doesn't have to. It's the same vector no matter where you put it. And then we use those same 4 formulas to change from one form to the other. None of that's changed at all. And that's all good? All right, our objectives for today, we're gonna add vectors. We're gonna add them in polar form. We're gonna add them in component form. Then we're gonna subtract them. This is so easy that even juniors can do it when they're not here. Have you added vectors before? Yeah, it's the same. So you know what to do. What did you do?
I did X and Y components.
Yeah. So they probably had you draw them a little bit. And so if you wanted to add vectors, you'd like just draw one 6 units at 40 degrees and then draw the next one head to tail, right? That's where you end and the next one where you start. And then you connect the dots. It's just as if you went straight across. And that's okay. Here's the steps. Don't mess this one up on the test. It makes me cry. Oh. Like on the last test. What's the real part of 26? 26. Yeah. Now, you could use the geometry method. You could use law of cosine. Do you have to do that in physics? No? Yeah. I can't understand why you'd want to force a student to do that. You have to change your axis so it's over here, and then you use alternate interior angles so you can get your 40-degree angle over here, and then you get your 52 to make a total of 92, and then you use the law of cosines, and then you use the law of sines for the angle. And 20 minutes later, you have to answer it's not correct. It's true, right? Now, in component form, you just add the components. So it's just like polar coordinates. Adding polar coordinates was terrible, so you changed them to rectangular coordinates and you changed them back. And that's easy. Okay. Like I said, here's how I actually did the last polar coordinate problem. I changed them into components, added the components, and then changed them back. My microphone's on the computer over there. You think it's picking up at all? Hello, juniors! We got it. Subtracting vectors. You just move the second vector so it goes the opposite direction, and then you add them. think we're done with babies crying for the year. Yeah. Oh, just in case, this is the opposite of the definition of opposite direction. It was in the book, and I thought, huh. So, if it's polar, you turn around and go the other direction. Whereas if it's component, you turn and go the other direction. This is so hard to teach. Oh, a problem zone. Plane is flying at 600 miles per hour in the direction of 90 degrees. And the wind is blowing at 80 miles per hour in the direction of 75 degrees. What method describes the actual velocity of the plane? So we got the plane flying, and the wind is coming from the side. From the side, like from the left, banging into it, pushing it. What's the actual flight path? Work that out. These people are getting paused for a second. They won't know it though, so I'm sorry I said that because I'm going to hit pause and then right away it's going to come back. Okay, just to make sure we understood what a direction of 90 degrees was, I made this map of the United States. We decided 90 would just be north. I don't know why I'm gesturing like this to the audience. Yeah, and we added the vectors. So to do that, in red, I use 600 cosine 90 and 600 sine 90. Got 600 for the components. Did the same thing for the wind. I just added the first components and the second components, and then I changed it back. And that's it. All right, now, a more realistic problem. The plane really wants to fly 600 miles per hour at 90 degrees and the wind is blowing at 80 miles per hour at 75 degrees. How fast and in which direction should the plane fly? It's the same problem, except now it's my unknown vector plus 80, 75. That makes 690. So you'll be subtracting the vectors. Good luck. 0. Okay. So, looks like we got to change the direction of the wind vector because we're going to subtract it. We change those vectors like we did in the first one and just subtract them. 522.3 miles an hour. 92.3 degrees. Yeah? Now, it's not going to be lesson math 2. It's going to be a worksheet. So, I forgot to give out the worksheet for the juniors left. Dang it.